So recording is started. So before I go into this slide, okay. So this is one of the lab. I'm going to share this lab later to everybody. This is a basic SRMPLS lab we have here. But I just want to share something here, not regarding SRMPLS right now. What I want to do is, I will go here, packet capture, start. So
Hello, I'm not able to hear. Is everyone on WebEx able to hear?
Oh my God, sorry.
So you were calling Ravi, I think he didn't heard it.
Oh, okay, okay, sorry. Actually, it went automatically unmute when I shared the screen, unshared the screen. So, in destination-based routing, what we are saying is there is a source, there is a destination. If there is a destination available, we generally go, how is the destination reachable to me? Okay, and we keep all the decision based on the path transit routers and the destination routers. In source, what we do in source routing, we take all the information and then decide which destination I will take. This is the core concept of source routing. For example, as I said, let's say from here I want to go to Marathalli. Earlier days, what I will do, I will just take a taxi, and however I reach Marathalli, that will be based on that. I don't have any Google Maps. I don't know where there is any traffic jam or anything. So based on destination, my travel will be. But nowadays, with Google Map, what is happening? I'm checking where there is jam, where there is road blockage. So beforehand, I am making a decision that I will go via this path, and not by this path. So this is, in a sense, source routing. It's not a destination-based routing. Okay, clear, everybody? Any question?
I mean, again, how it will be based on the source routing? I'm deciding where to go. Based on that, I'm taking.
Yeah, so basically, your source doesn't have any decision making in destination-based routing. Correct? It doesn't have any decision making. In source-based routing, you have the decision making power. You can decide, I will not take this path, I will take this path.
Okay.
So you see this diagram, correct? So basically R1 and R6. So base R1 already know that I have to reach R6. There are two paths. I have decided I will use R2, R3. Okay. In segment routing, there are features. Let's say R2, R3 has a delay. R1 will automatically decide I will not take R2, R3, I will go by R4, R5.
That we can do using T
In T, what is happening? Who is taking the decision?
source.
Source is taking the decision or
No,
RSVP
no.
is taking the decision?
RSVP is taking
So
the
that is not required, right?
signaling, yeah.
That signaling is not required. No other protocol needs to take the decision. The basic SR will take the decision. There is a difference.
Okay.
In T, you need a one protocol who will keep monitoring all the links, who will then decide, okay, this link is not available. It will then shut down. Here means basically it will optimize the tunnel.
Okay.
Here, what is happening? It will optimize, but it will optimize based on the SR information. SR has those capabilities inbuilt in him that it can monitor all the links and then decide which path I have to go. Not basic SR, SRTE with Flex Algo and all the other features. Link measurement, you can do that. But I'm saying that this is the capability source routing gives you. Which path I can take, how to take, everything you can decide. And this is where automation also will come into play. Okay. So let's.
Okay, so you meant to say the same thing we can do using MPLS-TE, but here, I mean, in MPLS we need RSVP to signal. For signaling, here there is no signaling protocol. So it's
Basically, you can say, see,
reducing the-
SR is an evolution of MPLS, RSVP, MPLS-T, everything.
Mm.
It is evolved in a single package. For MPLS, what you need LDP. Then for traffic engineering, you need RSVP. So you need so many things. In SR, you don't need all these things.
So it's reducing the overhead.
It's all not only reducing the overhead, it also giving you a lot of advanced features. We will see all those things. So how does segment routing works? What it is saying, when a packet arrives as a SR ingress node, what is an ingress node? If we just go back in this diagram, for R1 to R6, which will be the first ingress node? Are you sure? R1 to R6, I am saying which will be the first ingress node in the path? R2. Okay. So what it is saying, that when a packet arrives at the SR ingress node, it subjects to a policy. It's going into the core concept of SR MPLS. Okay. It generally doesn't happen in normal SR MPLS, but what it is saying, try to understand. Whenever an ingress node gets a packet, it's subject to a policy. What policy? If the packet satisfy match condition for that SR path. What it is saying is very simple. I get a packet, I see that label, I had this label, I will forward it based on that label information. Now, what it is saying after that, each segment in a SR path terminates at a segment endpoint node. What is an endpoint? R2 is an endpoint, R3, everything is an endpoint, but not an SR endpoint. What I'm saying is every node is an endpoint. Okay. Now, as per MPLS, generally what happens in MPLS? You go through the complete path. When you reach I think there's some problem in this mouse. So basically what is happening when you are going in an MPLS, when you are traversing a network, the last hop, the last route, before the last hop, what it will do? It will become a penultimate hop, correct? And penultimate, what you will do? You will do the pop action, correct? So basically, what SR has a very difference about MPLS is, rather than generating labels after labels and doing all this, it has a very different concept called adjacency seed and global seed, okay, or prefix seed you can call it. Based on that, it makes the forwarding action very smooth. We will know about it. So let's move on this point. Yeah, see, the essence of a segment is an instruction embedded in the packet header, which is understood and executed by the packet forwarding device along the way. So if you see this diagram, correct? This router, if it wants to reach here, it has two paths, correct? Now what it can do is, it can decide I want to reach here via which path, based on the instruction it has in its packet. Now let's say,
And that is not label.
yeah, what I'm saying is, let's say there is a forwarding happening. No, there's a forwarding happening. You want to reach this router. What you will do is basically, you will have all the payload. The payload is basically what? That data, which I've highlighted point. Data means the traffic you want to carry, which it can be TCP, UDP, any kind of traffic. Reflect the path in the packet. In your header, the path will be there from the source itself. Source has said, I am going via this router and I am going to reach this destination. This doesn't happen in destination-based routing. Source doesn't know that I am going to go via this hop, this hop, this hop. In source-based routing, source know I am going to go via this hop, this hop, this hop. Okay. So
this means router is not deciding. Source is telling that you just go
the
this way.
source will have all the information how it will reach the destination. This is the main concept of segment routing, or in a sense source-based routing. Okay, segment routing is just a name. So as we are only going about SR-MPLS, segment routing uses the existing MPLS data plane. We just seen the packet capture, right? How it was? There was what it was saying, MPLS label, right? But it was an SR label. So what it means is, when you are using label-based forwarding in segment routing, you are going to use SR-MPLS. Basically, segment routing will take labels from MPLS, not LDP, MPLS. Okay, from MPLS it is going to take, LDP is an application which uses MPLS. Similarly, segment routing is an application which uses MPLS. But remember, if you see the, sorry, if you see this, there's a mention I have.
LDP, we are just distributing the labels, right? So the same thing.
Yeah, it's in a sense distribution and controlling control plane information. So the way of controlling how the label should be assigned, to whom to be assigned, with whom the neighborship will be required, for that we need a separate protocol called LDP. But with segment routing, you don't need it. You can either control it via an SDN controller or via IGP protocol or even via BGP. Okay.
SDN controller.
Yeah, SDN controller in a sense, BGP, PSEP, PCE, XTC, these controllers can assign labels for you. Okay. Or you can do it via IGP, which is mostly used. Nowadays, 99% it is done by IGP protocols, ISIS or OSPF, or BGP in some cases wherever it required. But there are options for you. What is meant by control plane? What is meant by control plane? A control plane means a mechanism how it will be applied intelligently. Control, right? How I will going to assign everything by the protocol and rules intelligently. So to do that, we have different options. You don't need a separate protocol though. It's integrated within the ISIS, OSPF and BGP. For our case, just keep it like that. There is also another way to do it, as I said, via SDN controller. Okay, but keep it separate. So now,
this means here SDN controller is replacing LDP.
Yeah, it's already, even BGP, ISIS and OSPF was also replacing LDP. It's how you are going to advertise the label and bind it.
But for IGP, we are just choosing the path, shortest path or.
No, you are wrong. See here, whenever there is a prefix, you want to assign a label to it, right? For that you need LDP. But if you are using segment routing, you don't need LDP. Because segment routing will assign it via IGP protocol.
And OSPF ISIS?
Yes, they will assign it. And how they will assign it? They will take it from MPLS. We call it LSD process in XR. Label switch database. Okay. This has all the labels. From there, you will take the label and assign it to the prefix via the IGP protocol or the BGP protocol. Okay. Now, as I said, there's a MPLS data plane operations, segment list. We talk about it, right? So segment list is basically how many label stacks you are carrying. In SR-MPLS, it will all change in IPv6. SRv6, it will not be like this. Then it will become a different thing. But Understand the concept. What we mean by MPLS data plane operation of segment routing is how the label stack will be carried. BGP label, transport label, okay. There might be an L2 VPN label. So all those things, how it will be carried. Then, as we said, there are three, what we do. What are the basic functionality of an MPLS? I'm saying MPLS LDP. What are the three basic functionality? What do we, pop is the last. Before that, what we do? Push, swap, pop. Correct. So all the three functionality will be applied here. Okay. And then in the penultimate hopping, as same as MPLS LDP, you have the what you call explicit null and implicit null. By default, it will be implicit null unless you enable explicit null. Okay. Why explicit null is used? Because for QoS. Let's say you want to give some type of service QoS values. Implicit null will not carry that value. It will be lost in the label forwarding. To make sure that these values get passed to the end customer or the end PE router, so the customer gets the type of service he needed or the quality of service. For that, we can enable explicit null. Okay. But it has to be enabled manually. It's disabled by default. Implicit null is the default feature. Okay. So XR label space implementation. Generally, this is a PI session, but as we are from SP, we should know how the label space are given. So 0 to 15, we all know it's a special label. Okay. But after that, there is a label range. So 16 to 15,999 is your MPLS label space, and 16,000 after that to 23,999 is your sRGB label space. So if you see any label value from 16,000 to 23,999 in any customer network, it's a segment routing label. It's a very easy way to identify if customer is running SR or MPLS. Just go there and check the label number. If it's come under this range of 16,000 to 23,000 this, that means they are using SR MPLS. You have a very clear idea. Okay, don't get confused whether they are using MPLS or they are using SR MPLS. Rather than asking customer, which also shows a little bit of what you called in a sense, it will be a little bit of in a sense novice part, right? You go into a segment routing call as a CTS engineer, you type a show MPLS forwarding, and you then ask him what you are running, MPLS or SRv6. Sorry, SR MPLS. If you see the label range, you should know. Generally, if you are working every day, you will get used to it. That this is my label range, so that means I am running what? SR MPLS. Don't say SR. There is another SR which is called SRv6. So get used to it, because nowadays, after some time, especially Rakuten will come and many other customers, once they implement SRv6, you are going to use both the terms. So get used to it. When you are using normal SR, we called it SR MPLS. When you are going to use it in V6, we are going to call it specifically SRv6. Now, if I go to this part, yeah, this one. Sorry, this one. So what is this level value?
16,111.
So what is this?
SR MPLS.
And if we just open this packet, does it show any value here which clears that this is a SR MPLS? Anything here? Nothing, right?
Nothing.
You have to know by yourself. Okay, so keep an idea what is SR MPLS and what is normal MPLS. Okay.
Based on value,
Yes.
number.
Now segment operation, as we said, push, swap, pop. So 1 to 4 we are sending packet. So my first packet will go to 2, router 2. Then it will go to router 3, and then it will go to router 4. Correct? Destination. Now tell me, did you find something very interesting here? What is the label value? See,
Label
in
value remains
MPLS,
the
do you
same.
see this? No. Because it's a source base, it's going to tell very clearly, I just want to go to this destination. The path it is going to send, the path knows how to reach this 16004. Every router in the hop will have an entry for 16004 going towards R4. Okay?
So what swap we are doing it here?
Very nice question. What swap we are doing? So let's go to a lab router. So let's say we have this show route here. Now we see there are multiple routes we are learning, right? So let's take this route. Show route 2222.23. We see this. Okay. So now if I do show MPLS forwarding, everybody knows this command. Show MPLS forwarding. Prefix, then you give the prefix number 2.2.2.23/32. What it is saying?
Same.
So if I type show MPLS forwarding prefix 2.2.2.23/32 hardware egress detail location 00 CPU 0. So it is saying top bottom 1603. It's getting automatically muted, sorry. So what I'm saying is, once you take this, right, or there's another option, just wait. So if you type show Ceph MPLS, then you go for the local label. So what was our local label? 16,023 non-US detail location there it's also not getting. Just one second. MPLS rather than local label, I will go for this command. It's not showing here. Actually, there is a method. If we type show MPLS forwarding or basically go via the MPLS forwarding hardware detail, it shows the operation it's going to do. So here, there you will see it's going to say you, I'm going to do what? Swap. So what it will swap? It will swap this same 16023 with 16023 in the hardware. It will remove 16023 and basically it will remove that label and put a 16023 label. That's it.
Understand, but what is the meaning of doing it?
The meaning of doing it is, in a sense, you're saving labels. Now, let's say I'm using random labels like MPLS. What will happen then? You need an entry for, if we go by the diagram, let's go to the diagram back. If we go here, okay, then you will need one label for 2, one label for 3, right? So 2 more labels, and then you will have this 4th number label, which you are already using, correct? What's the meaning of using so many labels? If you can do it directly by one label.
Troubleshooting, we can understand. We can check, right, that levels are properly swapping and all. How we will identify here?
Identify, it's very simple, right? Programming, when you come, you have to check 2 things, correct? If you come to programming, see, first of all, as I was checking this output, any prefix I want to check, what will be the first thing I will check? The first thing I will check is show route for that prefix. Everybody should know that I have to check. The first thing is to understand the flow from a source. From this source, I want to reach a particular destination. For that destination, first of all, I have an entry or not in my routing table. This is the first basic condition. Next basic condition, for that route, am I getting a next hop interface? If not, that means there is a recursive route. If there is no next hop interface, that means there is a recursion where we will get the next hop interface. So how do I find this information from this table? what it is saying, BGP backup, and this is my primary. Okay, so if I type show route 3.3.3.112, I'm getting a next hop interface now. So this is what we call recursive route. What is the recursion? From BGP, there is a recursive lookup to IGP to get the next hop interface. Without a next hop interface, no route is valid. A route can only be valid if you have a next hop interface. So there is a condition called recursive route where what you do, one route shows it doesn't have a next hop interface. It gives you some particular IP, next hop IP only, but this IP is actually a recursor. That IP will again be looked up in the routing table and you will get a next hop interface for that. Okay, so this is what we call recursive route, and this is the first basic thing you should do. First, check out whether I have a route for it. If you have a route, next thing what you have to verify is information, how you are learning this route. The first thing says known via BGP, but see the information. There are a lot of information here. Labeled SR. This is a label packet. Then when you do the recursive lookup, it says known via OSPF, but again a label SR. So you know this is a label forwarding happening here. So how do you check label forwarding? What is the next command? Show MPLS forwarding labels. If you know the label, if you don't know the label, then prefix. Put the prefix 3.3.3.112. What is the subnet mask for this? Do you have any information? Yes, you see here. Sorry, I have taken this one. For that also you have the information here. So what is the subnet mask here? 2.23/32. So it says local label this, outgoing label this. So if you have an SR OM, MPLS OM enable, if you can do a trace route, you should have the same entry here and the trace route. It should not, it should be same. If it is not same, there is a problem. Okay. This is the output where we have taken. It's an output taken in RP. This is a PI output. This is not a PD output. In our case, we have to make sure that we take the output in both RP and LC. And they should be sync. Okay. The basic output should be sync. If I am using 16023 here, I should be also using 16023 here. Okay. So clear about this, how this thing is happening. Now, if you have any programming issue, you will have some variation here. Not this, in the detail outputs. Okay, some interface might be wrongly programmed, some label is not stale entry. Okay, those are the other things. But that is not our concern here. What we are right now trying to understand how SR works. So everybody have understood how this is working. And what will be the POP? So whenever we say the POP option, if we go, or rather than doing this, let's show MPLS forwarding. You see this? This is your POP. So what it will do, that means, so let's say I do this. I have the label value, correct? So I will go labels 2400. Outgoing label popped. So it is the basic implicit null. Okay, you see? Clear? So this diagram, what it's clearly suggesting you how this basic operation of a label happens. You can see it's been highlighted here also in red. What is the label imposed? What it is done? Where this impose thing happened, see the node name very carefully, node 1. Wherever the push operation happens, there will be the label imposing will happen. Okay. Now if we go back next, node 3, see, this is your pop operation will happen. What is the pop? We just check. It's an implicit null by default, unless you have explicit null enabled. Explicit null behavior in configuration for prefixed. Basically, what is prefixed? I will come. I'm just giving you the basic idea. Means this is the relation with MPLS. If you see so far, it's very similar to MPLS, except that common level part, it's very simple. So you will be very easily able to link it up with SR. There is not too much difference so far with MPLS. So basically, as I said, if you want to send the explicit bits, okay, you need a specific label. We called it special label, explicit null label. By default, implicit null, if a customer opens a case, is saying I am not getting QoS value after newly installing an SR based L3 VPN services. You should directly think there is something problem with the explicit null not configured here. Might be chance. Okay, because it's a newly one, they might have by default kept the implicit null. Okay. See there, this is how explicit null will be look. Once you configure it like this, the explicit null you have mentioned, then the explicit null will be shown like this. Otherwise, it will be shown what? Implicit null, like I showed right now. Okay, so next. Yeah. Basically, as I said earlier, very simple and efficient to work. You have this is a basic, let's say L3 VPN domain. You have a CE customer on both sides. There you are running BGP and core SR MPLS here. So there is MPLS side only prefix is there. One less protocol, no LDP. So you don't have to do any LDP troubleshooting. There might be some problem, no LDP neighborship. You have seen a lot of cases. Path is MPLS path broken because some router is not configured for LDP, or somebody has blocked a particular LDP port mistakenly by ACL or something. Okay, so you don't have to troubleshoot LDP. So there is only one thing to look up: SR. How it is managed by an IGP protocol. By default, 99% of the time, an SR will be managed by IGP. In very specific design-based scenario, BGP will be there. Okay. Now this is your basic L3 VPN. MPBGP, multi-protocol BGP, L3 VPN services configured between PE to PE. What they are doing, they are taking this CE packet, encapsulating within an SR packet as a transport, and then they are transporting this BGP packet via this SR transport to the destination. See, this is how underlay overlay concept is. Who is the underlay here?
MPLS.
MPBGP.
MPB.
Who is the overlay? Who is taking out the basic? If you go here in the PE, what you will see? If you go in PE router, if you type a show route, what you will see? Actually, you are right. Underlay will be your MPLS. Overlay will be MPBGP. So if you go in PE router, if you type show route, it will show a BGP route. That's it. Like here, right? If we go back to this one, if we see this output, right? Again, if I type a show route, what I am seeing, not this one. Yeah, this one. What I am seeing, this is a BGP path. Clear cut BGP route, correct? I'm not seeing anything specific here. But if I go in underlay side, means if I recurse look up it, what I will see here? There is a SR underlay here, which is carrying this BGP packet. Okay. Very similar. Here you are carrying a BGP labeled packet underlay via an IGP SR label path. Okay. Here what they are doing is they are carrying a BGP L3 VPN packet via an underlay SR MPLS path. Okay. Very similar to that same output, just the functioning is different. Verify the IP forwarding global table. What we mean by verify the IP forwarding global table? It's actually forwarding. When you say forwarding, you are coming into Ceph, the forwarding cache. Okay. Whatever we are talking so far is control plane, but data plane doesn't work with, means it's sync with control plane, but it's works in a different manner. It's program the thing in the hardware. So there comes your data plane part. So Ceph is your data plane protocol in a sense. It's managing how I am going to forward the packet actually in data plane. So if you see, everything is mentioned here. Global prefix, how many paths. If you see in this particular output, when I type show Ceph, let's see this in here in the live. So if I type show Ceph, same output, 2.2.2.23/32. What did I see here? This give me the first information. This is a prefix. This is a labeled SR. Okay. When it was installed or updated, September 7, 0157. What is the time today? September 13. Okay. So if a customer says my route is flapping, you check two things. First, you check the show route. In the show route, you see installed September 7. So this gives you a very clear idea when this SR label route was installed, and it's stable from September 7. Otherwise, what will happen? This will change. Any operations happens, this will change. I can clear this route right now and it will change. See.
If route flaps, that will change in both hardware and.
Not necessary. Let me just show you. 23, actually clear route. IPv4, unicast. Okay. 2.2.23 /32. Okay. Now let's take the show route option first. When this said it was installed now, this is a route flap. Even if I manually cleared it, it's basically a route flap. The route was gone and it came up. So there is a new installation type. Now if I took a shows ref output, when this is said it's installed, updated. Why? Because when the information goes out from the control plane updates the same to the data plane. Data plane updates the same information in the where? Actual data plane, correct? And this will be the update part. So data plane is showing you here that I have updated this information. Something has happened here. This is a clear signal from this timing part that some changes have happened in my table. Some path changes, something has happened. That's why this is an updated information. Otherwise, it should be this output. If everything is stable from the day one, it should be like, if some flap happens, it will get registered as here by the timing. Timing is giving a hint, something has happened in this prefix. Okay. Now the next path. You see there are two paths here, backup and a primary path, correct? See this, check this very clearly. Label context, the label it is going to use, and then my two paths. One is 111, another is 112. Whichever is a backup path. Whenever you see this backup, what do you mean? What is this meaning? It means there is a
alternate path.
Fast reroute enabled. Fast reroute enabled. Basically, in SR means there will be SRT enabled. So not SRT, TILF enabled. What is TILF? Don't worry. Just think like fast rerouting. Primary backup path is there. So there is a fast reroute enabled here. So there is a backup path here. There is that means this path is protected. If a primary path fails, traffic will switch to the backup path. And we can see this information here. Then we can see how this backup path information is, what label it will use, and how the primary path information is, what label it will use. See, now another thing, check very carefully. The label imposed. What are the label imposed? 16023, 16111. See this difference. Why? Why this label is common, but this label is not? Remember transport label, remember? So if we go back to this capture, this capture, what was the transport label? Toppest one will be your transport label. In a label stack, the toppest one will be your transport label. So after Ethernet frame, which is the toppest label? 16111. So your transport label is 16111 here. Your BGP label is 16021 here. You want to verify? We can verify this. See, what is my transport label?
111 and 112 is BGP label.
So how do you going to check this part? This is my transport label and this is my BGP label. show MPLS, forwarding, labels, put the label value 16023. SR prefix, detail. Sorry. What does this say? Prefix. Okay, it's not going to show here. Then there is another option, show MPLS label table. This is the label table. Okay, so you type 16023. Label. Yeah, sorry, this is the one. Label table detail. Now you type 16023. So it says 160 is registered to both OSPF and BGP. Okay. Show MPLS LST forwarding labels 16023 detail. It doesn't show any label, but if I type 160, what was the another label? 11, right?
No, 16111, no single.
16111. It's not showing here. Show MPLS LST forwarding labels. No, then 1 second. There's one command which can help us here.
BGP learned labels, right?
Yeah.
So show BGP label.
16023. Okay, so this is you will only get the local labels here. So these labels you are learning it not from it, right? 160 this 11 you are learning from your neighbor and you are installing it. So how do we verify this, right?
Where we can see that getting it from the neighbor and installing it.
Yeah, that's MPLS. Sorry, show MPLS forwarding. Sorry, labels. Local label. Put the label 16023. End of stack. Detail. So here if you see this label, I'm only checking this particular label. Okay. Label is SR. Source is RIB. Backup flag. RIB 7. 1 second. Show route. What was the route? The specific route we have is 2.2.2.23 detail private. Now see who is assigning you the label. Backup path labels 160 the BGP. Okay. So in the RIB you can see this information. Actually there is a save command. I'm forgetting that
So
command right
BGP
now.
label
There also
doesn't
you can
show that?
verify it. So basically here you see this is the BGP label. Okay, but if I go to the 1 second, this adjustment has to be done. If I go to the show route, what was that? 2.2.23. If I do this and let's check the recursive route now. 3.3.111. Okay. Now you see this 3.3.111. You remember the previous command we did where we used to know that this is my BGP label, correct? Now if I do this 3.3.111, what is happening? What is the label value I'm getting? 16111. Where I'm learning from? OSPF. OSPF, I'm learning this label. So if I took this same information and try to map it in the Ceph side, wait, I'll just take the normal out. Show Ceph 2.2.2.23 detail. So what do I get? So you can see this information here also, but to specifically know, you can just take a route private detail output. That will clear you out. So this, how this has been then checked in a seeing perspective. If I am seeing a screen, how I will see it from left to right. Upper level, top layer label. The top label will always be on the upper side. The label which is at the bottom will be on the right side. Okay. So based on that, you can get the idea. Now you want to know specifically where this label is learned from. Take this out, private output. Detail private route output for this prefix. You will get to know which protocol is giving me this label. Okay. So now you are clear how this stack is done. Everybody, how to find it out. So first you need to get this safe output. If you have any confusion, how I am learning this, where is the transport, how should I know where is this particular label value, correct? So best answer is, first of all, remember this rule, where you have to go, top will be left, right will be bottom, first thing. How it is learning, take the particular prefix where you are learning this label from. This 111 is advertised by this next hop. Take its route private detail, you will know which protocol it is advertising this label. Okay. Now,
So Naresh, to Kanan here.
see, I've said this, right? Two paths, prefix it, egress PE, BGP VPN label. You see, this is highlighted here. So BGP next hop, egress PE, prefix it to egress PE. The prefix to reach the next hop PE. Egress PE means the prefix to reach the label, to reach prefix label to reach the next hop PE router. There were what 16111 was the next hop PE router there to me, right? So it will be my on left side. After that will be my BGP label. Let's say there are two layers here. One is a BGP label, one is your IGP label or the forwarding label. So your transport label will always be the
Different side.
first left-hand label. First left-hand label will be because that's where the operation will happen. Once it goes to the next hop router, what it will do? It will going to check a packet has come to me. Sorry, it moved out. Yeah, a packet has come to me with a label. For example, here a packet will go to 16002. It checks 16002. Okay, the packet has come to me. It's a valid packet because the label is mine. It will then check which side I have to forward. It will then try to look up for 9001. For 9001, there will be an entry in its step table. And then it will forward that particular label. So if we go in the lab, this is 812, right? So if I say this, which router the interface, this is gig 001. So if I go to the diagram and check gig 001, so it will be this router. If I go in this router and just type the same command, what I will check for? Show MPLS forwarding labels 16023. There is no label. Why? Think why? How it is forwarding then? I don't have any label here. 16023.
Top the level.
Swapping is okay, but how am I forwarding this? Here,
That is a segment, right? The above segment.
here I am saying, right, 16111, I am going to forward it here. So if I go here, the top level is what?
16023. That will be
111.
port, right? That's why, yeah. Port.
It is not the 1611 router. The label 1611 is not advertised by this adjacent router. Okay, it is advertised by this router, PE111. You can get the hint. 111 is the host name, so loopback is 111. So that's why what it is doing, when it gets a packet 16111, it is going to pop it and then send it forward. Okay, this is the backup path.
Is that 16112?
Backup path.
Okay.
You can see here, right? It
Mhm.
mentioned here backup. So you have to remember this, not always necessary that my top label left. What I mean to say is this 16002 will not be processed on the next adjacent router. There is no guarantee of that. Okay, it can be a multi-hop away. This is just the information that before we reach 9000 9001 router, this label 9001 label router, there will be a router with a label called 16002. That router can be 1 hop away adjacent to me, or it can be 100 hops away. Okay, don't take this output guaranteed that if this is showing like this, that means the router is directly connected. Because if that's the case, how this happened? The label is here, but I am checking here. Correct? So this is the concept of segment routing. You are understanding now. I am going via labeled path, but I am not even taking that label path label information required. Why? Because this top label information is already present in this router. If this router gets a label 16111, it knows what to do. If we go by this diagram, if that router gets a label 16002, it knows what to do. It needs to what? If I just consider this 16002, I need to pop it and forward it to this interface. That's it. Okay?
But I'm not understanding this part.
What I am saying is, when you are forwarding, you need the transport label. This is your transport label. Now, as a router, if you are in a router, you check this output, what you are expecting, my next hop router should be this. But I'm saying this is not guaranteed in SR. For example, if you see this here when we checked on this router, what was the next hop? 1611 111. Then if we go in A11 and if we check the show, basically if we check the forwarding table, what did we see?
16111.
So 16111, what it is saying? It is not its own label. If it was its own label, why will it perform an operation? This 16, what I am saying is, in this router, 1611 is this router. Okay, there is a middle router in between, which is also running segment routing. But I can just say directly here that you go to 1611 and then go to this router 160123. Okay, I don't need to give the information in this particular label stack that you have to go to A11. Why? A11 by default knows once I get a label for 16111, I will pop it and forward to PE111.
So in MPLS, where exactly we are popping the label?
In MPLS, what will happen? In MPLS, you will need the entry for this A11 router in this label. Here you don't need it. Okay. The reason here you required both this stack, because this is a multi-domain SR. There are multiple. Here there is running on OSPF. Here this is in ISIS. This 16023. That's why this stack is there. Otherwise, it will go in a single level. Okay. So understand the advantages of SR. This is one of the core advantages of SR. Anybody have any question, guys? I'm asking the remote guys. Okay. Then this is the same thing. We have checked show MPLS forwarding. If we do show MPLS forwarding, it is going to show you. Now, if you see here very carefully, it's showing this 24032, correct? This, whenever we do this, right? So if I go here, sorry, not this router. Let's A12. Let's come here, show MPLS forwarding. If I do this, what I see all the labels and the outgoing label. For our case 16023, correct? It's saying 16023, you go out as 16023. Why? Because that's what we need. We need to go 16023, we will swap 16023. Internally, there is an underlay of another segment routing label path, which is from 16111. Okay? So this is the same output. But if you see there is some 2400, 2401, why this 2400? These are your adjacent label. Remember, segment routing range ends where? 23999. So after 23999 comes the adjacency labels. These are not your global. They should not be unique. They will be only unique to the local router. So if I want to reach gig 001, okay, for that I have an adjacent route label called 24,000. Okay. There is a global label prefix seed.
What is that global prefix seed?
Yeah, I will come. And this is the adjacent seed. Why I am saying this all? Because we are going to go into this part now. But there is a concept of this. Okay. This is what we are saying. See, this is a remote prefix, neighbor prefix, explicit null. Sorry. And then ECMP. If there is a ECMP, there will be multiple, but the labels will be same. Why? Because every router knows what to do with this label. So you don't need to worry that ECMP, I should have another label. I will forward that packet with that label. The local router will automatically find out what to do with it. Okay.
Clear.
If it doesn't find out, your packet will drop. You will see many cases, customer is saying my SR path is not working. You do a trace route MPLS, you see suddenly in one router, packet is getting dropped, no label. There you can see this kind of scenario. In your router, you will see there is a path label available. In that router, you will go and find out that the path is broken.
If there is no label, then what would be the next step?
Then you have to troubleshoot why there is no label. Is the configuration done properly? Are we learning that thing? Is there any programming error? All those things comes into play. But at least you have to find out first that there is no label there. So MPLS OAM, SR OAM makes this life much easier because you can just do a trace route MPLS and get all the label values on the path, how it is doing this. Okay. So basically, as I said earlier, right, the global block, how it will be assigned. 16,000 to 23999, how the labels will be assigned, how it will be mapped out. So this is the same thing. LDP label, the LDP values we know from where? From after 16 to
23.
no 16 to 15,999. After 16K to 2399 is your SR label range, and then after that is your local adjacency label range. So basically what it is saying is the programming behavior. So let's say IGP, there is a prefix. You install that prefix in the RIB. I showed, right? Show route. But then what? Who will going to provide me the label? The label will be provided by IGP. How it provides? It ask MPLS. So if we go here in the lab router, so let's this is 812. So we take that same example 2.2.2.23. So here we are getting a route from BGP. Okay. BGP can also provide SR label. Here you can see. Okay. Now there is a label from BGP. Now, if I check show MPLS, what you got in BGP, how do you check the prefix detail? Show BGP. What?
Never know.
If you don't know all, then 2.2.2.23, you get the detail like this. Okay. Show BGP. If you don't know the address family, customer cannot provide you the information. You just type all. So it will automatically tell all the address families, and then it will put the prefix entry. You have to put the specific prefix you want to check, and then detail. Sometimes you will want to filter it out. Multiple address families you are learning, so you can just filter out by the RD or the address family specific. So here what do we see? This is the entry. This is my label. Where I am getting it from? SRGB.
What is that? SRGB.
Segment routing global block. Show run config segment routing. Okay.
So there is a separate block who is providing this label.
Yeah. So if you see, I mentioned it, right?
Hmm.
We have configured this. We can also do some mapping. Like for example, these two routers will only use global block 16,000 to 17,000.
We have to configure it. There is no default.
By default, it will use this range. You can configure it also. Okay.
Naresh, just one question. So what is the
Now,
address family that uh,
if I,
Naresh?
this is how I know that this is a segment routing global block. I'm getting this information. Yes, Sharanya.
So can you hear me? Hello?
Hello.
Can you hear me?
Speaker
Okay.
is- No, it is working.
Hello.
Sharanya, you are asking something?
Yes. So my question is, what is the address family that you enable? Like, is it labeled unicast?
Yeah, Sharanya, you are asking something?
Can you hear me?
Okay, just one second. I think there might be, I understood what happened. Yeah, please go on now.
So my question is, what is the address family that you'll be enabling? Is it
Hello.
labeled unicast?
I think
Hello,
she's
can you
not
hear
audible.
me?
Anybody else? Able to audio hear her?
Okay.
Okay.
Kannan also was trying for some time.
Yeah, I think.
Hello.
Yeah, Sharanya, please.
Okay, so what is the address family under BGP that we'll be using? Is it going to be labeled unicast?
Yes, you can see it here.
And one more
Prefix
question.
it, yes, it will be carried by, yes, labeled unicast.
So one more question here. So when we use the label unicast under BGP, it generates its own label. So when you, so and segment routing is usually enabled under ISIS or OSPF, that is IGP. So it picks up the, so when ISIS generates a label for a particular prefix, does BGP pick up that and just advertise it? Or how is this whole thing when the BGP
So
is
there
involved?
are two options. You can do that. You can generate the label in IGP and then BGP will carry that label information. Okay. Second is you can generate the label from BGP itself. You have both the options.
So when I generate it from BGP, SR just utilizes it. Like BGP picks it up from MPLS and then SR just uses it.
Yeah,
Correct?
basically every label we see here, right? That's what actually I was going to tell. Any label you see is going to be assigned by MPLS. All this BGP, so if I type this LSD, so if I type just show MPLS LSD, I actually typed it, right? Then show MPLS label table. Let's do this. Show MPLS label table. What do you see here?
I see that OSPF has generated and yeah.
So if you see all the special labels from 0 to 13 are used by LSD. Then
Okay.
Then OSPF.
Then from 15,000
This is also LSD.
LSD. Then from 16,000 to
OSPF.
23,000 it is used by BGP and OSPF. Both these are the two protocols running here. Both are using this sRGB base, this global base they are using. So basically they are going to ask the label from MPLS LSD that on this range I need this for my this prefix, give me the label. MPLS LSD will give them the label. Okay.
Okay, got it.
So if you see this 24001, this is an LDP adjacency level. Okay. LDP A. So if you see this, it's going to give you the complete details here. Start level, there the 16,000 start level, 16,000 size is 8,000. 16,000 plus 8,000 how much? 24,000. So up till 24,000 you have this range. Okay. Segment routing adjacency IPv4 label. So understand the concept. if you want a label, you need to get it from where? MPLS LSD. LSD is not LDP. It's called label switch database. It's not labeled. Okay, it's not an LDP protocol. It's a different thing. This is a label switch database. Okay, it manages all the labels. So if you type show MPLS LSD private, what do you see here? How many labels I have in label manager? 9,000. Maximum label is 1 million around, right? Yeah, 100k. You can say 102k labels I have maximum. How many labels I am using right now? SRG block. So if you take this total block, see, basically I have blocked it, right? Once I said SRG global block, I have blocked that range. Nobody can use it except SR. So MPLS cannot keep it as free. It's already taken. It might not be utilized right now. You might be using only 100 labels or 10 labels.
We are requesting labels from MPLS.
Yes.
Then where this SRGB is coming?
SRGB is the name given for this block.
Oh.
And this is not SRGB,
So
this is SRLB.
This block
This is segment
blocked.
routing label block.
So this means this block is blocked by MPLS basically.
Yeah, it is blocked for segment routing. Why? So if any, let's say we have given 8,000 labels to segment routing. So the router has freedom till 8,000 to assign labels for segment routing within this 8,000 labels. No other protocol can take labels from this range. That's why it already been blocked and counted. That's why if you see what it's saying, label manager label count is 9,000. It has already taken all this label into blockage. It will not allow anybody else to use these labels. If you need something else, you can take from the rest. See the free ID count? From there you can take the label. So everybody has a clear idea now about label part? Okay, so basically we know that segment routing we can do interoperation with MPLS. Why? Because when segment routing came first time, the main core protocol for transport was MPLS. So if you are going to use segment routing, you need a functionality where the migration can happen seamlessly. Any new protocol you bring into technology, you must have a back-end compatibility with the previous technology. Otherwise, no one is going to use it. Because they need to migrate, so they will require back-end compatibility. So segment routing gives you that back-end compatibility. So what it means by is this, you can enable a network where you can have both segment routing and MPLS, but you can make sure that only MPLS is used for forwarding. Then with a single line of command, you can change it to be segment routing. How? MPLS SR prefer. Within the IGP, once you give this command, all your MPLS label will be swapped by segment routing SR label, and SR will become your primary switching technology. So once you give this command, SR is your primary switching technology. Once you remove this command, and if you have MPLS, MPLS is your primary technology for forwarding.
Once I remove, LTP comes into the picture. When I add, LTP will go off.
Yes. So this is how the backup compatibility is there. Okay. Say, let's say any migration happened, what you have to first check, customer has enabled SR prefer or not. Otherwise, their segment routing might not be working there. It will be MPLS based only. Okay.
So every configuration I can do previously, that will not.
You can just run MPLS as it is. You configure the SR, basically SR block and everything, because MPLS will not going to conflict, right? MPLS has a different range by default. It will not use the 6,000 range, 16,000 to 24,000 range. So you configure your label, SR label blocks and everything, and then slowly and steadily you enable the SR in network part by part. And the thing is, you can intermediate. Let's say you have, let's take this. Let's say you have a router, multiple regions, Kolkata, Mumbai, Delhi. You migrated Kolkata to SR. You kept Delhi and Mumbai as MPLS. Then you migrate slowly Delhi to SR. In this migration, the time when you migrated Kolkata to SR, there will be no problem running with Delhi and Mumbai, which are running LDP. When as soon as the packet goes to an LDP domain, LDP switching will happen then, not SR. Okay. So basically a node which is sitting between an SR and LDP domain can understand both the protocol. It can easily translate from SR to MPLS and MPLS to SR. Okay. So don't worry that if you see an issue, or it's not an issue, I'm saying if you see a router where there is MPLS LDP after that and only SR, let's say there are right and left. Left side is only running SR MPLS, right side is only running MPLS. It will work. Many customer you see after migration, most of the network will be like this. They won't be running full SR MPLS. Slowly, steadily, they will move to SR MPLS. Okay. So mapping server is basically, see, in the end, you want to map the SR, right? How you will map, how the label value will be assigned. So there are different options. You can use a mapping server. What it will do? It will map your labels.
IGP is doing it, right?
It's doing it, but it's a manual, right? Every node you have to go and do it. What happened? You have a centralized node and you want to map it. I told you SR will always go via what? Automation concept. It was not only bring with the source routing, it was also built with the concept of making sure that everything can be automated. If everything has to be done on every single node, what's the meaning of automation? This CLI behavior is basically what? And this mapping server has another thing. As I told you, right? A particular node which is sitting in between an SR domain and an LDP domain. How it is handling this? Let's say SR label comes 16,020, but it has to forward to an MPLS level then 8,002. How it will do it? It maps that SR label to the LDP level. That's why it's called mapping server. Okay.
So we don't need any extra configuration from LDP to
No,
SR?
it automatically happens. This is what the interoperability is. See, this router, that P6 router is a what? SR LDP border router. So it will.
It's not assigning, I mean, LDP to SR mapping is not happening, then
Your path will be broken, network will be in trouble. That SR part will not able to communicate with LDP, LDP will not able to communicate with SR. This is basically all the things which I have explained is written here. So if you have any time, you can just go through it. You will be able to easily understand what it's meant. What I am saying is very clear. If you have a mapping server, okay, it will make sure that your operability, interoperability will happen smoothly. Okay. Now comes the control plane. Remember, you are asking that what is the prefix state, what is the adjacent state, how we will configure. So in LDP, we have to configure LDP separately, correct? You will go into MPLS LDP, then you will give a loopback as a router ID, then you will add the interfaces separately, right? Here you don't have to do this. You go into the IGP protocol, for example, let's say OSPF. Within OSPF, you go into you enable the option. I will go here. These are the TLVs. That's the other thing. So this is for ISIS, for example. So within the address family, you have to put metric style wide in ISIS because ISIS has two metrics, wide and normal. Normal metric cannot carry this extra TLVs. Any information, this segment routing, all these things have came later. ISIS was developed much earlier. OSPF was developed much earlier. They don't have the technology to process this. So they have added this information as TLV. So whenever you added this information as TLV, so for that you have to mention the protocol that you process this information. So this is how you enable this. For ISIS, what happens is this metric has a limited size. So what you do is you make it wide, so it can carry extra TLVs and it can understand. So that's why whenever you are using ISIS, for all this advanced feature, you must enable metric style wide. Otherwise, it will not work.
For OSPF, it will be
OSPF you don't need, it's automatically managed. Because in OSPF, it will be LSA based, opaque LSA based.
LSA.
Yeah. So this is the segment routing IPv6. This is going to enable your
SRv6.
IPv6 means SRv6. And if I go previously, segment routing MPLS will.
MPLS.
But remember, this is only enabling your SR capability on MPLS data plane. If you are running a LDP also, which one will be preferred by default? LDP. Unless you mention here SR prefer. After this, there is a line keyword you have to mention called SR prefer. Then only segment routing will take the primary function.
That's a good thing actually.
This is actually
migration will be
so this was done based on the thing that MPLS is already legacy. It's running already in every customer environment. So by default they can make a mistake. So give them an option. After only configuring that option, they will have the right to use SR. Okay. So if anybody mistakenly configure this, he doesn't mention that keyword, there is no impact.
I mean, you can do it partly actually. You don't need to do it.
Yeah, that's what I was explaining before, right? That you can
So
keep
that's
enable.
with
Yeah.
a big network. Then it's a,
Any protocol will be built like this. Okay, that's how it is. Now comes the prefix set. What is this prefix set? Basically, this is what the explicit null is. Yeah. Global segment managed by routing protocol manually configured. What it means by is very simply that for your node, there should be an identifier. Every node should have a single identifier. It's a logical interface, so it's not dependent on your physical interface. Your physical interface goes down, you lost your identifier. That is not going to happen. Like BGP, you have an identifier. Every node has an identifier. Now that identifier, you can map with a label, and that label will be unique to that node. Right now we are seeing in SR MPLS, right? The label value is common. I am going through 100 routers, but the last hop router label is only carrying that information. In a single domain, it will be like this. Multi-domain, there will be another transport label, like we see in that output. So what is happening? You are identifying that router by that one unique label, which we called what? Global prefix set. This is a unique label. You would go, if you see this output,
that unique level you said, that is a global prefix set. 15999 something that one.
if you just check this, show safe, if we go. If you see this output, right, 16023, 16111, what are they?
Adjacency prefix set.
These are adjacency prefixed, are you sure?
Because 16023, we can see this 16023 on all the routers.
Let's go to this router.
That should be unique, right? Global prefix set would be unique.
Let me show you. Here, I am just typing one command. It's not even an output command, okay? Router, OSPF. Prefix seed index 111. What is my interface? Loopback 0. Show MPLS forwarding. What was that label?
16111.
16111, right?
Oh, it's adding 111 with 16,000.
So, what I said, prefix seed index 111. Where is my label starting from? Range?
16,000.
16,000. So,
And
16
in
plus 111 is?
16,111.
So, what is my prefix seed?
111.
So, if I type show MPLS forwarding label 16, nothing is there. Why?
It's popped.
This is your label. This is what your prefix seed is. This is your global seed. This router is known to every segment routing router by this particular level value. And how it is get computed? By your global range and by your prefix seed index.
So this prefix seed index should be unique for each router.
Yes.
So other router.
Let's say if you have a duplicate, you will get a log.
But we are getting this. No, we are not getting.
In Bharti, you will get lot of time cases where there will be a conflict arising because there is a duplicate prefix seed learning. I'm not sure how many times you have seen. I have seen couple of cases where their whole router reachability gone down because segment routing got a duplicate prefix seed. To prevent loop, it stopped the forwarding. So prefix seed is global and unique. So you see seed value, seed index. Now there is an option. You can give an index or you can give it absolute. What is an absolute? You just mention it. Prefix seed 16111 will be the prefix seed for that router. That's it. You give an index, it will take your global range and then it will add the index part from the global range. So let's say your global block is starting from 17K. If you just type index, it will give what? 17111 like this. Okay. But if you set absolute value, then what it will done?
Only 17.
17111. Or you have to mention that value completely. Okay. See, it's an index is offset, absolute is the absolute value. Okay. Now, if you see, all these are highlighted. What it is saying, the configuration. This is how the configuration. See, absolute. There are two options. You can say index or you can go for absolute. We have done the index part. So what it did after global box, whatever I have given, it has added that value. So I has 111. So 16 plus 111. If my global block started from 17K, 17 plus 111. In absolute, you have to mention the exact value. That's it. Now, if you check the database, in the database, it will give you the data. Prefix seed index 1. Algorithm this.
Is there any advantage over this absolute?
Absolute or prefix? See, if you have a network, you don't want your prefix seed to be used by every other duplicacy case, right? So you will make sure that it's absolute. That's it. This router absolute. This is my prefix seed. Finished. So in future, you might say the customer will say, okay, this router 8, that's the label 16888. They get easy to understand. Now you see all these flags, re-advertisement, node seed, any penultimate hopping or not, explicit null, value local, all this flag information will be mentioned here.
0 means not set.
1 means enabled.
Set.
So n is equal to 1, only one flag is enabled. What is n? Node seed. Node seed is the what? Prefix seed. Don't get confused, it mentioned here. Okay. So if your prefix seed is enabled, in the flag you will find this information. Okay. So this is for ISIS. See all the flags here saying attach, node. In OSPF there will be some specific more flags because what? OSPF has area concept. ISIS also has, but OSPF areas are very strict, stringent. ABR border, they have different routers. ISI is what you have, L1, L2 routers, that's it. In OSPF, you have an ABR, ASBR, you have an NSA area. So you need all this information to be put, right? So for that, you need different things. So if you go in OSPF, you will get the label value like this. What it says, flag 000. What it means, you will not get this. If I go there, 1 second. So if I go in this router, so here show OSPF database, okay. Then if I go into self-originate, opaque link, opaque area, see the flag. Where is the flag value? Maximum round. Point to point, right? Wait a second. I have enabled some features here. So area. Okay, you have to mention the specific area also, but it's okay. I can just filter it here. I can just filter the value of flags. You see the flag, right? So that's what I'm actually saying. So let's begin with flag. So flag 040 prefix this. So if you means by force, if we convert it here, as we said, if we convert this part here, this flag, okay, so it's basically like this. So if you say 04, how many bits we need to enable to make it 04 in these zeros? If we go by binary, right? So first bit is your what? 1, then 2, then 4. So hexadecimal 4 means you need to enable this bit. So bit L, what is mean by L?
Least significant.
Local.
Local.
This prefix seed has a local significance. Okay. So this is how you read the flags. For example, there is a router. There should be an explicit or implicit null should happen there. It's not happening. Programming issue. Maybe. How do you verify in control plane? You take this data in OSPF. You like this in ISIS. Show ISIS database. Router name verbose. Okay. And then you check these values. If these are, let's say, disabled, it should be enabled. Then there is a problem. You have the configuration. It should be enabled, but it's not getting enabled. Then you need to take the particular show tech traces, investigate, and try to find out a common bug, or go to the DE and ask him the question that I have configured it. It should be enabled here. It's not getting enabled. Okay. Adjacency seed. You asked, right? Now we talked about global seed. Now we come to the adjacency seed. Why it is required? For adjacency communication. Global seed, I know this router R7 is this label.
Understand.
R7 is label, let's say 16777. But locally, I have to communicate to that router without the global seed, like MPLS, right? As we said in MPLS, right? We used to see in the end, we know that a router is directly communicating via the transport label at the top. In the back end, it's working similar to MPLS. The label switch will be the adjacency label switched. How you will know this very clearly? When you will use SRTE TILFA. What will happen if you have a TILFA? The backup path, specifically if a TILFA PQ node backup path, you will see there that the backup path one hop will be an adjacency seed. It will not be a global seed. The Q node. See, if in TILFA what happens? The PQ node calculation happens. I know many of you are not clear about that. If we go in just for a brief explanation. So if I go here, just so let's say this is my router. Okay. Now this router is reaching this router by this link. This link flaps. So there should be a backup link, correct? So backup link is like this, correct? But what will be my PQ node here then? There's a PQ concept here. A router which doesn't go via this link, it's not going to use this link at all. This failure path, right? What will be that router? What is your P space and Q space? I know I don't want to go there. Basically understand that there is a concept called P space and a Q space, by which you get to know that if this link fails, what will be my next best option to go to this PE111. Okay. So for that, when you program it, what you will do is to reach PE111, let's say you get a Q node as A13. This is the node via which you will go directly to PE11 when you are failing this link. So what you will do is you will program this node's adjacency label of this path. Okay. What I'm saying is you will program this adjacency label, not the global label here. Okay. And then you will put the global label of this router. This is how it is used. So I'm saying what I want to say it very clearly. All this we see, right? That the global label is only used for forwarding. Internally in the router, when it's forwarding, it's actually using the adjacency label.
You have to recognize me That it's
Yeah, local, because see, in the end it has to go via the adjacent router, right? And adjacency label will be used to transport to the adjacent router. That's it. Why otherwise it is been kept there? But for us, in real means when we see in the upper side, what we see that it goes via the global level. Okay, because global level is mapped. It's internally we know that to go via here, what you have to do is you have to use the adjacency level.
Here the concept is little.
So let's actually do one thing. So let's enable in this router here. So here also we will enable MPLS OM for clear understanding. I'm just enabling on 3 routers, okay, just to get us some idea. Trace route for 2.2.2.23 source 1.1.12. Sorry, trace route PLS IPv4. Okay, I have not enabled it here. See what it is saying. It is using 112, not 111 right now. Okay. So if I say source, let's say source, I think I have to give an IP. So it's using 112, but let's again try. It's going to use 112. So let's make it 222.21. Now you see. What you see? It's putting an implicit null. You see this part? So in whenever you are checking it upstand, you see that this is using the global level. But if you just type show adjacency, okay, detail, show adjacency private, I will go for. If you see the adjacency information, how the SEP table is built, any idea what are the information is used in SEP table?
Next hop.
It requires ARP table information, it requires adjacency table information, right? All those information it takes, label read information, all this it takes, it creates a then cache. That cache is then kept where? LFIB, your FIB table, right? Your FIB table is the information it is getting from everybody. So your local adjacency, point to point interface, that's your adjacency information. So it shows the adjacency MPLS. Show MPLS forward. So if you see gig 001, just remember that part. So gig 001, what is the label for one particular prefix? Let's say there is a prefix called 111113. Who is 11113 or 333111? Who is this guy? Show route. Let's check. 3.3.3.111. Okay. If we type this, where it is going from? Gig gateway 0. So if I just type trace route 3.111, it's see what it is saying. 16111 global. But if you see the table, what it is saying, adjacency information, where it should go for
24,000.
24,006, pop it out. So local communication, when you need, you will use this. But if you are using a global communication, you are going to use global table. Okay? So 1111 121. Okay, 8 will doesn't have this. It should be 11, I guess. It doesn't have this entry 112 110. Actually, I can show you that thing. It's better. Show route. Let's see. Where is that entry? 112. Yeah, this is 3.3. Show safe. 3.3.112.
Why we are in so hurry to complete it in this just 2 days?
Because we don't have time. Our Rakuten training will start, right? So timing shortage is there. Shows PLS forwarding prefix 3.3.3.112.111/32 private detail. It's actually not TLFA here, it's just doing FRR, okay? Otherwise, we could have seen that part, what I was saying. Adjacency. So adjacency segment, what is this label persistency? You will find out this 16 means, let's say a label has been assigned. Global seed we have configured. Even in adjacency, let's say there is a label 24002 assigned. The router link flagged. For that local adjacency, the link flagged. It came up after 5 minutes. You will find out the same label is assigned. It's not been assigned to anybody else. So for 30 minutes, that label is still for that particular interface. Once it comes up, it will be assigned the same level value. So don't get surprised, okay, my link flag, why this label is again assigned. Don't think that there is a programming stale entry issue, okay. For 30 minutes, the same level value will be assigned. So see, OSPF never repelled. You see the adjacency seed? So OSPF, when it is trying to communicate with the neighbor, the label adjacency seed label it is going to use is this one. Okay. In our case, if we go here, show OSPF neighbor detail. So 111, this is my interface. Where is the adjacency seed? Here, protected. Unprotected 24009, protected 240. Okay. What it means? That this seed is protected by whom? 24009. But 24009 doesn't have any protection, right? When it will become active, when this goes down, one path is already down, so how can it be protected then? $24,000-$24,001. In FRR, if you have two paths, backup and primary, primary is protected by backup. Primary goes down, backup becomes primary. Who will be protected from? There is no path, right? That's what. So if we go back to the slide. Adjacency seed label. So if you see for the next hop, this, you will use this adjacency seed to reach. Okay. Yes.
Slide more we have left. I lost my concentration.
I was saying that, yeah, we have a lot. I think we'll be, how much, what is the time right now?
Completed.
Okay, almost, give me 15 minutes. I think we will be done. So this is how this adjacency seed is, okay? are we guys clear now what segment routing is, how label will be allocated, what will be the global prefix, what will be the adjacency prefix? Adjacency means you have to be very clear, it will be the locally connected interface. Locally connected interface to my next hop routers. Okay, this is my adjacency. Adjacency means connected to me, adjacent to me, neighbor. But global is your identifier.
Unique identity.
Unique identifier for every node. You think it as a OSPF. OSPF identifies everybody by its router ID, correct? Similarly, SR identifies everybody by its global label. So these are the flags. What will be the backup value and everything? Why this backup is required? I told you, right? In SRT, you will see this. How it is required. If we go ever in SRT training, we will see this part where how this is used. In ISI, it's also the same command. It's just the command has been mentioned in the backup and all those values. OSPF example, adjacency label. It's the same thing. I think we have seen it already. Prefix segment. ECMP, by default, ECMP is there. So let's say if we have two paths, common metric, both the path will be installed and both the path will be load balanced. This is by default in both OSPF and ISIS. You don't have to worry that you have, let's say, 16 common paths with common metric. They will be load balanced between them. Okay. Adjacency segment, how it will be forwarded, how it will be distributed. These are all the things here mentioned. All node use, this is the global. Okay, this is after that. Adjacency comes after global block, which is 24K. This is, see, again you are saying combining IGP segments. To steer, you need this adjacency segment. Okay, that's why we are coming into this question. What is this combining IGP segments, steer traffic on any network? What is meant by steering? If you know that, let's say 1 has to go to 5, 2 to 4, which is my primary path. Let's say 1, 2, 4, 5. This is how I am going. If I go here, 1, 2, 4, 5. This is my primary path. There is a delay here. Think it as a Google map. It's showing red. Rather than 1, 2, 4, 5, I will steer the traffic to 1, 2, 5. So to do that, what I will require? I need to know this adjacency segment also, right? When I go to 2. See here, that's why they are saying, right? This is your, see the packet, 16004. What is the next thing below this? Adjacency segment label. Why? It goes to 4, it pops out the 4 label, and then we know this adjacency segment. See, if a packet comes to 4, if it pops out this 4, this upper label, it sees this adjacency label. Where does 24045 is suggesting? What I said, adjacency means locally connected. If I go there in my table, if I type the show MPLS forwarding, I will see that this adjacency label is forwarding towards 5. So this is how it is. So in TILFA, what will happen? Your backup path will have this 2 entries. One is your global label, one will be your adjacency label. So rather than having the R5, this R5, see what can happen, I will tell you otherwise. Let's say, let's say R4, rather than using this adjacency label, we use 16005. Okay, 16005. Now I go to R4. R4 is saying, okay, you have come to me. I have to go to 16005. I see the label value 16005. In R4, supposedly it says to reach 16005, I will go to 2 and then to 5. What you will do? Your TILFL is messed up, right? You have a link failure, let's say in 2, or 2 node is down itself. You are reaching via 3 to 4 so that you can reach 5. It's in convergence. R4 doesn't know right now, it's failed. To prevent that, what you are doing is, when you are installing the backup route, you are saying go to 4, but rather than saying him in the lower level that you go take the calculation in your hand, you basically check the adjacency level. Don't use the global level. By it, what you are doing, you are forcing R4 to use this link. Because he is seeing adjacency level of the connected link, right? So once it sees that connected link, it's not going to think about what it's in my table. It's going to see this is the link, this is the label. This label forwards to my adjacent link. I'm going to forward it to my adjacent link. There is no calculation there anymore. Now you're understanding what the logic I was saying earlier. This is again this adjacency sync concept, why it is used in DR, BDR, in DIS election, in ISIS. It's also again used. Okay. So OSPF LAN adjacent type 8 extended link. So basically what it's saying is this, for this LAN in DR, BDR election, OSPF uses a different opaque type. By default, OSPF in a single domain you use opaque type 10. It's mentioned there in this PPT, but I'm just saying by default it is used opaque type 10. If it is a, let's say, multi-area or multi-AS, multiple OSPF domains are there, then it will use opaque type 11. So say here for this LAN segment, if you are advertising your adjacency seed, you will use opaque type 8. All these opaques are the new information like segment routing and all those things included in OSPF so that it can communicate with other routers using this advanced technology. So for OSPF, segment routing was inserted via these opaque types. In ISIS, it was done by TLB. Remember this. This is all those explanation what I was saying, right? Segment routing advertisement is basically the same. How it has been advertised, wide metric, all those things, the configuration part. We have gone through all this, right? We have gone through all this. So if you need just for, let's say, if you want to use what we called for reference, you can go through this. And this is just, remember this is IPv6 unicast standard IPv6. You can use ISIS segment routing on both IPv4 and IPv6. Okay, but this is not SRv6. Please remember, I'm saying SRMPLS you can use for both IPv4 and IPv6. But regarding SRv6, it's a different concept. Okay. So let's see if I have to show something else. Actually, we are on the last slide. So these are basically all the label values. Means if you want to check very carefully what are the metrics, what are the flags, all these things are highlighted here. Sometimes let's say you want to check any. Sometimes if you want to check anything specific, that's how you check. Okay. It's the same thing in OSPF. How it enable the configuration I have already shown. In the lab, it's also there. Auto database. This is actually the OSPF command, show OSPF database self-originate for yourself, how you are generating, what kind of LSS you are generating. For example, if I go here, if I go here, show OSPF database, opaque type, opaque area, self-originate. If we just type this, so you will see this, all these routers are there, right? So if I just go opaque type database, self-originate, so you will see that which are the opaque types I'm using. Basically in database, it shows you what you are using. So there is a normal your LSA router link. You know, right? In OSPF, there are multiple LSA types. But if you are using a type 10 opaque LSA, then it will show like this. Okay, so this is how you using. How many routers are there? We know these are all the routers who are using this opaque type and communicating with me. We have shared the database. You want to see the detail, you just type this command, you will see what details there is. What are the range? What are the flags? We've gone through this, right? If we have some flag enable, the flag value will be in hexadecimal. You convert it, you will got what bit it is. It's little difficult in OSPF. In ISIS, it will be easy to understand. So these are all the information which we talked about. So in this algorithm part, it will come in, if we ever talk about flex algo, then we will check this part, okay? So this seed index, prefix, all these things, we are clear. What is seed index? We have seen, right?
Global index.
In globally, we configure the seed index, right? So if you have a seed index 1, what will be the label value?
16,001.
But in adjacency also, it will come like this. So adjacency start from 24K. So you have an index value 1. 24,000 plus 1. So 24,001. You have an index value 111. So it will be 24,000 plus 111. So it will be 24,111. Okay. You can see it here. We have a prefix set index what here? Show run router OSPF. What is the prefix set index here? 12. Self originate. Let's see. Let's come down a little bit.
16,012 it should be.
Prefix length value, seed value, prefix this, okay, seed index. Here, level value. See, this is for some router, I think, some other router. So here it is using 24,009, 24,010. For our side, it will be 24,012. Okay. Other side, for us, it will be 24,012. For example, link type 1, see, 12, this for this prefix, for this link, we are using 12. Basically, if we go here, what it is saying is
So this is actually this 24,000 is adjacency.
Adjacency block. In that block, by index, you are adding the value. Okay. For example, if I give a specific area and element, we get that particular value. So how this is generated based on the index. Anycast prefix set. Anycast prefix, I will go very short. We don't have too much time. It's basically in a way things like this. There are 4 routers. Let's say. Let's go to the topology. I'm just going to give a short explanation because this is actually not too much related to segment routing. It's related to Anycast concept. So let's say we have a router called A22. Okay. Now what we can do is we can advertise a prefix like an Anycast. This the loopback of A22 as an Anycast prefix from these 2 routers. So for this A12, this Anycast prefix means I can reach by any means. Any router who has the shortest path, I will go via that. I don't care from where it is coming. For example, what sometimes they do in server, right? They configure the same IP on both server interfaces and they advertise it. So it becomes an Anycast prefix. So for me, it comes, let's say one is coming from one domain, another IP, same IP is coming from another domain. It doesn't matter. It's an Anycast IP. I will take it as an Anycast IP. We have to mention it as Anycast specifically. So what will happen is, if that IP, let's say, goes down in one domain, I have a reachability from another domain, I will go from there. That's it. Otherwise, what will happen? Conflict will happen. You have a same IP from different locations you are learning from. There's a chance of a loop, right? But if it's an Anycast, it's a different concept there. It means that it is reachable from multiple locations. You can go from anywhere. That's why anywhere, right?
Anywhere.
That's why it comes to Anycast. It's a short concept. I have not gone into detail because I don't think we have time for this. So basically you have to put this flag there then. Okay. See, the same thing which I was saying. Same level value will be assigned, advocate from both the nodes. For you, it doesn't matter if any one node fail, because this is Anycast, you will automatically switch to the other node. Okay. This is the BGP way of assigning prefix set. Generally, you need it for very special cases. It is used, all the SP used it, but you used it in a very special case. There are some specific topologies where it is used. It's not used like everywhere. Okay. BGP LU, yes. Segment routing based network, you integrating BGP LU, you will use this concept. Here also we have in the lab, I have used it. But remember the core base I have already explained. IGP based SR MPLS. This is the core of segment routing. Any customer you go, they are going to use this. Very few customer will use the BGP based SR MPLS. And for that, there is a specific way of troubleshooting. It's all mentioned here. Actually, I will not be able to go out, detail on this because I think I have to go separate for this. But I hope everybody is clear about BGP, sorry, not BGP based, SR based, IGP, SR MPLS, how it's working, how it's going to be forwarding, the way an SR packet is forwarded, how the instruction is carried, how to check the label stack in a SEP table, left to right. Toppest label, leftest label is your toppest label. In a SEF output, whichever label is in your left, leftmost corner is your toppest label. That's your transport label, the one you should be worried about. Okay, next label is the next label in the stack. So for you, important is the leftest label, so you know where it is going to be forwarded. Correct? Anything else, guys? And the another important thing we have seen is LDP SR integration. How SR prefer gives you the advantage to enable and disable a SR in an LDP domain like a switch. You can just remove the config, it will be LDP based. You remove the you add the config, it will be SR based. So all these things you have to go through this lab. I will share the lab after this session. Go through the lab. Just understand this concept. You have the slides, you have the commands there, right? Go check the commands, run those commands in the lab. You don't have to configure anything, it's totally configured. Try to understand how it is configured. Okay, try to check the packet flow and try to verify how this label works, the label stack and everything. So next time if you see an SR case, you can do the basic troubleshooting, right? How the label is run. You can ask the customer, okay, tell me where this label is, where this prefix is. Okay, did we check point total flow? What is the flow? Many people ask, right, what is the network flow? Network flow is nothing but this information. How it is learned, from learning how is the transport, how it has been learned in the hardware or the FIB, all this output, and keeping this output highlighted. So if let's say an escalation comes, he knows, okay, this is prefix you are troubleshooting. I can see the RIB entry is correct. I can see the MPLS entry is correct. I can see the SEF entry is correct. So he becomes very clear, okay, so this is my entries, all looks correct. We might have to check something else, or there is a problem there. You might not be able to find out. The escalation lead might be able to find out. His jobs become easier. Collecting this information hop by hop basis is your network flow. Okay.
Okay.
Okay, guys. I think we will end it. Unfortunately, we could not go out for the BGP prefix, but it's a big concept, and I cannot think we can do it in 5 minutes. Okay, so I think we will have to stop here. So please go through this. Have SR, MPLS, IGP based. I'm not going for BGP based for you guys. Please have it very thoroughly understanding, because tomorrow I'm telling you it's going to be very difficult. SRv6 concept is totally new. It's worked in a very different way of method, and most importantly, whatever you are learning today, the concept is similar, but still without knowing this concept, you won't understand a single word tomorrow. So please learn this. Why? Because a customer is getting joined, Rakuten, who are going to deploy SRv6. So if you are getting an SRv6 case, the team is expecting that you can at least do the initial and basic troubleshooting. So for that, you need to understand how SRv6 works, right? You cannot say to customer, okay, SRv6, what to do next? That cannot happen, right? And also remember, I stated migration cannot happen in a single day. They will be running SR MPLS right now. Over that, they will migrate to SRv6 slowly and steadily. So half of their network, or let's say 70% of their network will be what?
MPLS.
SR MPLS. Over that, there will be running SRv6. So what you have to do is,
Oh, their network is SR MPLS.
yes, they are migrating to SRv6 now. This is a new technology. Except SoftBank, no customer has done this yet. Okay, they are going to be the second one. Most of them are testing right now. So when they are going to migrate, so you will get this kind of scenario. SR MPLS is not working with SRv6.
Tell me one thing. I mean, if I am having MPLS, we can migrate it directly to SRv6.
You can, but I have not seen that done, because most of the customers are running SR MPLS. They are moving to SRv6 now. So have this concept clear. Otherwise, what will happen? You will not understand SRv6, then you will go into a case, you will not be able to troubleshoot SR MPLS, forget SRv6. So go through the slides, go through the lab. Without lab, you will not understand. I am telling you very clearly, theory doesn't work in our field. Go to the lab, do the commands, run again and again, try to understand how the labels can be seen, what is a transport label, how it is programmed basically. If you know all these things, I can assure you there will be zero escalation on this. Otherwise, if you don't understand, you are going to get catch by the customer. That's it. Okay, guys, thank you very much. I will end the session now. Okay, I will end the session. Any question from remote people? Krishna Raj and everybody, any question?
Only 1% left, everyone.
Okay, I think okay guys, then I will stop. I will stop the recording now. Thank you. I will share the PPT and everything after that.
Which tea habits is